Okay, today in physics we're talking about free fall. So I want to start with a what do you think question. So here we go. How far does the object travel if it is dropped from rest and hits the ground with a speed of 10 meters per second after traveling for 1 second? So I'm going to pause and give you an opportunity to think about this and come up with an answer for how far. Okay, how many of you guessed 10 meters? And how many of you guessed 10 meters because you used the equation d equals v times t? Okay, v equals d divided by t is for average speed or average acceleration. And so that equation doesn't work here. And the speed of 10 meters per second is instantaneous speed. And for the ball to have traveled 10 meters, that means it would have to have been going 10 meters per second the whole entire time. And it wasn't. It was dropped from rest. So we are going to investigate how to figure out how far an object travels when it's dropped. First of all, Galileo came up with what I think is pretty much a conceptual method to figure out the distance of a falling object without doing a lot of math. So here's how it goes. In the column on the right, it shows that the distance changes by odd numbers. So let's go through this chart. So in 1 second, the object travels 5 meters. The way you figure that out with Galileo's method is you take the first odd number, which is 1, and you take it times 5. And so 1 times 5 is 5 meters. So in the first second, the change in distance from beginning to the end of 1 second is 5 meters. Okay, if you want to figure out how far the object travels in the second second, you would take the next odd number, which is 3, and then always times 5. That would give you 15. So in the second second that the object is falling, it travels a distance of 15 meters, which would be a total distance of 20 meters. In the third second that the object is falling, to figure that out, you would just take the next odd number, which is 5, times 5, which would give you 25 meters. So in the third second, the object actually travels a distance of 25 meters, which is a total distance of 45. And in the fourth second, you would take the next odd number, which is 7, times 5, which would give you 35. So in the fourth second, the object would actually have traveled a distance of 35 meters, a total distance of 80 meters. So now you try to figure it out. I want you to try to figure out, with Galileo's method, how far would the object travel in the next second, and then what would the total distance be for 5 seconds? Okay, so what you should have gotten is the next odd number is 9 times 5, which would equal 45 meters. So in the fifth second, it would have traveled 45 meters in just that 1 second, but a total distance for all 5 seconds would be 125 meters. Okay, so Galileo came up with that really amazing method. But maybe some of you don't like to do things so conceptually, so mathematically you could have solved for it with the equation at the bottom of the screen. The equation is d equals 1/2 gt squared. But this equation only works when the initial velocity is 0. So be careful there. D is your distance, g is your acceleration due to gravity, and t is your time. Okay, so again, what we're talking about today is we're talking about free fall. What is free fall? Free fall is when something is falling and is falling when there's no air. The only force that's acting on it is gravity. This is called a vacuum. A vacuum is where there is no air. So free fall again is where an object is falling, there's no air resistance, and the only force acting on it is gravity. Here on Earth, gravity causes all things in a vacuum to accelerate at a rate of 9.8 meters per second squared. That's here on Earth. Okay, this is in free fall. Well, this means no air resistance. G is the variable that stands for acceleration due to gravity. So we will say g equals 9.8 meters per second squared here on Earth. G also stands for grams, but that's an SI unit. This g for acceleration due to gravity, is a variable, like when you're solving a math equation and you're setting it up with your knowns and unknowns. So we can solve for the instantaneous speed of an object at any point, especially when it hits the ground, by using the equation v equals g times t. Now, this equation only works when the initial velocity is at rest. The initial velocity has to be 0. So you would have your initial velocity equals acceleration due to gravity times time. What if I wanted to solve for the total distance? Okay, that's the same equation you saw before, which is 1/2 g, which is acceleration due to gravity, times time squared. And again, this equation only works when your initial velocity is 0. But we don't always have our initial velocity at 0. Sometimes we like to throw things up, and sometimes when we have things, we like to throw them down. So the initial velocity is not 0. So in that case, you would use the following equation: d equals initial velocity times time plus or minus 1/2 gt squared. Or another equation you can use is final velocity equals initial velocity plus or minus acceleration times time. Now, how do you decide if you want positive or negative? How do you decide if you want to add or subtract? Sorry, on the right-hand side, that kind of got squished together. So if the object is going down, you would put a negative sign. And if the object is going up, you would put a positive sign. So you would subtract if the object is being thrown down, and if the object is being thrown up, you would add. That's how you figure that out. Another equation that you guys might use, if you don't have time and you have no way to figure out time, you can use 2 times acceleration, not necessarily acceleration due to gravity, just acceleration, times distance equals final velocity squared minus initial velocity squared. Okay, so let's look at throwing an object upward. Of course, in free fall, so there's no air resistance. The only force acting on the object is gravity. So follow the picture below if you like. Okay, what happens to the velocity of the object when you throw it upwards? So if you look at the picture, what's happening to the vertical velocity going straight up is that it's decreasing. And it is decreasing by 9.8 meters per second. What happens to the amount of acceleration? Well, the amount of acceleration is dependent on the amount of force. And the force is gravity. And the force of gravity is not changing. So the acceleration is not changing. So the amount of acceleration throughout the path of an object going up and coming down is 9.8 meters per second squared. The amount of acceleration does not change. Okay, is the acceleration positive or negative when the object is moving up? If you remember, up is a positive. We're going to put a positive on that. And when moving downward, we're going to put a negative on that. Okay, so again, we have this equation that we're going to use when we throw an object up or down. D equals initial velocity times time plus or minus 1/2 gt squared. We're going to put a negative if the object is going down, and we're going to put a positive if the object is going up. Okay, let's look at the highest point. So the highest point, what is the velocity? And what we're talking about here is the vertical velocity. Well, it's not moving up anymore. Just like for a brief second, it kind of stops. It's 0. Your velocity, your vertical velocity is 0 meters per second. Well, what's the acceleration? Well, if it's not accelerating, it would just stay stuck in the air forever. So it is still accelerating. And what causes the object to accelerate? In this case, it's gravity. And gravity is not changing. So even at the top of the path, the object is still accelerating at 9.8 meters per second squared. Okay, that's it. I hope that went well. Thanks, guys.